So here we have a function is a relation in which each possible input leads to exactly one output. We say the output is a function of the input. Another way to look at function is that a function is a relation in which each element of the domain corresponds with one element in the range. There is one and only one output with each input. And last, a function is from set A to set B as a relation that assigns to each element in X exactly one element in Y. Okay, so here we have some examples. So looking at the definition, we can apply that to see which of these are functions. It's kind of hard to see here, but we have a 1, a 2, and a 3. I'm going to write them here so you can see them. And on this side, the numbers are 6, -8, and 6. So here we have 1 is going to 6, 2 is going to -8, and 3 is going to, this is, 6. So what you want to do to figure out if it's a function, ask yourself, is 1 going exactly to one element in the range? And 1 is going exactly to 6, 2 is going exactly to -8, and 3 is going exactly to 6. So we say that this is a function. On the next one here, we have the numbers are 8, 7, 2, and 4. And over here we have 5, 9, 3, and 5. So here 8 is going exactly to 5, 7 goes exactly to 9, 2 goes exactly to 3, and 4 goes exactly to 5. So they're each going to just one item in the range. So that's still a function. Here we have 7, -5, 6, and 8. And on this side, we have the number 30. So here, again, we ask the question, 7 is going exactly to one thing, which is 30. 5 is going to exactly one thing, which is 30. 6 goes to one thing, and 8 goes to one thing. It happens to be the same thing, and that's okay, because each of these is only going to one thing on the range. So this is still going to be a function. And the last one, you have the number 8 here, -5, 8, and 6. So here is 8 going to just one thing on the range? And the answer is no. 8 is going to 3 different numbers in the range. So that makes it not a function. So the important thing is that in the domain, this number should only be assigned to one range. Okay, letter E. So we ask the same thing. Is -2 going to only one thing? Yes. Is -1 going to one thing? The answer is no. -1 goes to 3 and it also goes to 4. So automatically that makes that not a function. Letter F, they give us the information a little bit different than this picture, but you can draw your own picture. So remember the input is your domain. So we have the number 0, 1, 2, 3, and 4. And then for range, we have -4, -2, 0, 2, and 4. So 0 is going to -4, 1 goes to -2, 2 goes to 0, 3 goes to 2, and 4 goes to 4. They're all going to just one element in the range, so that makes it a function. Let's look at page 18. Determine whether each relation is a function. So again, as I mentioned, they give you a set of ordered pairs. If it helps, you can make yourself a little graph here or a little picture. So the domain is all the first numbers in here. So we have 0, 8, 6, and -3. And then the range is the second numbers, which is 9, 7, 8, and 5. So 0 goes to 9, 8 goes to 7, 6 goes to 8, -3 goes to 5. So you can see that all the domains are going to exactly one item in the range. So we say that this is a function. Okay, number 2. Again, you can draw yourself a picture. Eventually, you won't need the picture, but for now, if you need it, it's fine. So the domain is 4, 5, 7, and then there's another 5. I'm not going to include it twice. And then the range is 0, 10, 8, and 7. So 4 is going to 0, 5 is going to 10, and then 7 goes to 8, and then 5 goes to 7. So notice that 5 is going to 10, and it's going to 7, so it's going to two different items. So we say this is not a function. So a shortcut that you can think about here is, notice in our domain here, the first components were all different and it was a function. Over here, for 5, notice that 5 appears twice. So if a number is repeated, it's not going to be a function. So let's look at this one. We have -5, 6, 3, and -9 different. So that's going to make it a function.